सो आज हम कुछ प्रॉब्लम सॉल्व करते हैं. तो दिस इज द फर्स्ट प्रॉब्लम in which this is a bar is placed on a hinge support. Okay, and there is one end is attached with a rope, and this end is attached with a rope, and this end is attached with some weight. So in this question we have to determine the minimum value of W for which this bar should be in equilibrium. Okay, so first of all we have to determine what is, because these two rope having different tension, because this rope passes through this pulley having a friction, and which coefficient of friction is 0.2. So that's why in these two ropes there is a different kind of tension. Okay, and one more thing, that this T1 should be greater than T2, because if T1 is greater than, then this will keep this bar in equilibrium. Otherwise this will, if this will higher, then this bar should be goes upward. So that's why here this T1 should be higher. So how can you proceed to calculate this first T1, and thereafter we calculate the value of T2, which is equal to W. Okay, so now come to the question, that first we have determined the load, what amount of load is acted in this bar. So let us see that this triangular load system is having base is 3 meter and highest load is 100 Newton per meter. So the total load is 1/2, 3 into 100, 150 Newton. And where it is at, this is 1/3 from point C, means from here 1/3, while from here this is 2/3. Okay, so the from C, that is equal to 1 meter, and as we know that this T2 should be equal to W. Let's suppose this is equation 1, and now we come to this part, that first we equate the vertical load and horizontal load. So these two equations you can use to determine the reaction of RA and HA. Okay, and apart from this reaction, if you take, because as we know that for equilibrium system, overall moment about a point, either that end or another end, should be equal to 0. Okay, so T1, this is T1 sin 60, this is one moment is working at this point, and there's 150 Newton for triangular load system, and this is the A point. Okay, so we have calculated the total moment on this bar about point A. So T1 sin 60 is T1 sin 60 into this distance is 5, and that will be rotate this clockwise. 80 Newton per meter, again it is clockwise, and 150 Newton per meter, this will rotate anti-clockwise. So that's why this is 150 into. So by solving this equation, we have found that this value is T1 is 50.80 Newton. Okay, now come to this question, that the second part, how can you proceed to determine the weight W? So since the surface is with friction, this is some kind of explanation I have write. If you don't understand, please read this statement. So as I earlier told that the value of T2 should be less than the value of T1, and the ratio of tension, we know that the ratio between these two tension is T1 by T2 equal to e की power mu theta, where mu is the coefficient of friction, theta is the angle formed between these two tension. So this is your, so this is vertical, so this is 90 degree and this is 60 degree. So place a parallel line, and we found that this angle is equal to this. Okay, so total angle is 150 degree, convert it into radian. Okay, and by using this mathematical formula, we can calculate the value of T2, that is equal to 30.05 Newton, and that T2 is equal to W, so this is 30.05 Newton. Okay, now the next question, in this next question there are two parts. Determine the equivalent stiffness and natural frequency of the system. The first part, this 25 kg mass is fixed between these two springs. Okay, while this second question, this 25 kg mass is fixed between the mid of the single spring. Okay, so how can we proceed to determine this equivalent spring stiffness and natural frequency? So come to this point that how can we proceed. So as we know that the total load, because this load is distributed in this and in this, so the total load, let's suppose this is distributed, this W1 for this load and W2 is for this, so the total load remains W equal W1 plus W2. So the extension from this X1 is W1 by K1 and compression is W2 by K2. Since this same load is distributed uniformly in K1 spring as well as K2 spring, so the total or the extension or compression should be equal, because there is no change in length. So if there is no change in length, this W1 by K and W2 by K2 is equal, and we have calculated the W2 value. And if we put this W2 in equation 1, W1 plus W2, so as we put the W is W1 1 plus K2 by K1, and this remains should comes to be W1 equal to K1 plus K2 upon K1. So what is the value of W1? W into K1 upon K1 plus K2. Okay, and if this X1 equal to W by K1 plus K2, since this is, we know that total extension or the extension in the spring is W by K, means total load upon total stiffness. So by comparing this equation, because in this question the extension as well as compression is equal, okay, so X1 this K is equal to total stiffness K1 plus K2, so 12 plus 20, 32 Newton per mm. Okay, so by putting this value of K into this equation, we have calculated the value of frequency. Okay, now in the next question, so before discussing the next question, we have to know about that fact that the spring constant is inversely proportional to the number of coils in it. How many this spring is having this number of coils, this is inversely proportional to the stiffness. Okay, so if since in this part this same weight is situated in between this spring, so if in mid, so the half of portion is covered in this upper portion and half of covered in lower portion. So the stiffness is K1 and K2, and that is equal, and the K upon 1 by 2, because half is covered in above, so K into 1 by 2, so this is 2K, and the total equivalent stiffness is 2K plus 2K, because this is a parallel combination, so 2K plus 2K is 4K, and that is 48 Newton per meter. And by putting this equation in this expression, we have calculated the value of frequency, and that comes to be 6.98 Hertz. Okay, so today is this is final, and in my next video we have upload notes as well as video on elastic collision of the bodies. Okay, thank you.